So, hi everyone, thanks for joining the presentation of our paper on exchange requirements to support demand-side management using BIM and Building Automation System domains. I am Flavia and I worked in the paper with Conor, Susana, Roberto, Donal, and James. As an introduction, I am part of the BIM European Training Network. I am particularly focused on the integration of BIM and Building Automation System for demand-side management. And this was the first paper that I worked with as part of my PhD. In the paper, we not only define some high-level exchange requirements to support this application, but we also propose the use of an approach that could make the integration between BIM and BAS more semantically interoperable. So why demand-side management? Well, demand-side management is one of the services that can be hosted by what we call smart grid-ready buildings that integrates and link elements from smart grid and smart buildings to defer grid reinforcement, mitigate grid stress conditions, and lower energy price by balancing the energy supply and demand, which can particularly address the intermittent nature of the growing market on energy, renewable energy source, and the growing energy consumption, global energy consumption, from which buildings are currently accounting for 35%. So how does demand-side management work? So it basically integrates building resource to the grid operation and market. It can be the loads, or it can be the on-site generation. It fosters the active and dynamic energy consumption management, can be electrical or thermal loads, by leveraging the exchange in information, so use of information, communication frameworks, embedded device, that is sensor, actuators, and controllers, and support. By doing this, it supports grid stability and reliability, promoting also from the building perspective, this operational cost reduction in response to marked incentive programs. How can BIM and BAS support that? So the integration between BIM and BAS can be valuable, can provide valuable, accurate, and real-time data for the management and control of the building assets, enable context, what we call context-aware demand-side management, only based on the grid signals and market signals, but also on the current and real-time operation of the building, all the context that involve the building, also location of the equipment, schedules, comfort levels. So in terms of BIM and BAS, BIM can be valuable for providing information on the special context, and also it's valuable for providing cross-domain interoperable workflow, while BAS strengths are focused on the specifications of the building energy systems and the capability of monitor, control, and actuate building assets. So the overall aim of the paper was the definition of exchange requirements to support this context our demand-side management using BIM and BAS information. And also we've proposed the use of a methodology that translates these exchange requirements into an ontology. It can capture semantic descriptions, concepts, and relationship between the exchange requirements, and is valuable for allowing later on validation and consistency of the information. And based on these exchange requirements, we also introduced an approach for currying the BIM and BAS models, or linked BIM and BAS models, into generating a common data model according to that list, that set of exchange requirements. The added value for obtained from this paper is that with the integration of BIM and BAS, we can have a more granular and adaptive demand response to the grid signals, ability for the integration of both domains. BIM BAS integration is a topic that has been is being studied in the last couple of years. And from these studies, we can see that it's the representation of BIM and BAS has been proven to be feasible, linking IFC with BACnet or Loanworks that are open communication protocols from BAS systems. But despite it, while they demonstrated that they can be connected, we still have limitations in terms of representing control functions and in terms of representing the use of multiple communication protocols at the same time. In terms of mapping, we've seen the use of relational database being a powerful tool for linking BIM and BAS. However, the mapping has been quite customized and manual, which can be error prone. And lastly, in terms of application, most of the applications are focused on the on-site monitoring for fault detection and diagnostics, and also for 3D visualization, linking the physical and digital object. But there is a lack of building to grid applications using and exploring BIM and BAS together. As a research gap, we narrowed down to two main ones. So there's a lack of semantic interoperability to drive and connect heterogeneous BIM and BAS datasets, source and domain representations. And as second, there's a lack of a BIM and BAS common data model that can be used to assist demand-side management control mechanisms from the building perspective. So the methodology that we use is basically starting with the definition of the use case. In this case, we are applying the integration between BIM and BAS for dynamic demand-side management programs. In terms of business process, I will detail later on, but the idea is to represent how is the information exchange within the BIM, BAS, and the grid domains in the design and the operational phase of the building. Then we are defining the exchange requirements in three main levels, so field, control, and management level, and proposing the use and the capture and translation of these exchange requirements into semantic descriptions to be presented and formalized into an ontology. The main contribution of this paper stops on the exchange requirements, but we present the whole idea of how they are going to be used and how this can be used in the whole approach of connecting the domains and applying the demand-side management. Here is a better explanation of that. So the idea is that in the design phase, we created a BAS model in reference to the special information from BIM and the specifications from the building energy system, the equipment, and specifications of the control logics for the demand-side management, generating a BAS model. And the way we are proposing to integrate these models is basically having here the definition of the exchange requirements being translated into an ontology that can link BIM BAS model according to the exchange requirements. This link between those tools and the code generated to attend those exchange requirements help us to provide and to active a common data model, which is validated against the exchange requirements, and if valid, applied into optimization context, our demand-side management algorithms that rely on the BIM BAS information that we have here, BAS real-time data, and grid signals. Now, in terms of the exchange requirements, starting from the field level, we have the special information being exploited to locate the system placements, which can be used for optimization strategies based on thermal zones and the location and the space. And also there is the focus on the system's information to be also individualized and having all the descriptions and geometric representations of the device, and in terms of physical connection as well. So both physical connection between the device and also grouping device into a main system. So grouping into a chiller, grouping a HVAC equipment into booking different equipments into an HVAC system, so booking different lighting related equipments into a lighting system. In terms of the control level, so the idea here is to represent the logics and define the exchange requirements for representing the logics. So in terms of data points, having both physical and virtual data points, defining set points, defining the logical connection, so relationships between input and outputs of the device, the control scenarios, so actuation scenarios for the operation, and the events from the demand side management, and time frames as well. And finally, from the management level, we have both a little bit more of special context information that can be provided by BIM in terms of occupancy schedules, the thermal comfort requirements that I mentioned before, some expected values, and also this data acquisition that connects the building and the grid, receiving the signals from the grid and also the signals from the sensors to evaluate and optimize the input for the optimization strategies. So with all of this, we defined with the base of the exchange requirements into an ontology, we could define the domain knowledge of a demand side management that will further be able to link BIM BAS models using the reasoning and the semantic descriptions capabilities from the ontologies, creating a common data model. Our proposal so far has been this common data model based on a schema agnostic, but we are seeing towards the end of the paper, after finishing the paper, we've seen that there is this tendency and quite promising use of graph-based knowledge representation for the common data model. So as a value proposition, the integration of BIM and BAS domains could allow us perform this fully automated context-aware demand side management programs that allows these individualized load management, providing cost reduction, reduction of energy consumption and cost reduction because of the market incentives, and while maintaining the target needs from the building and comfort requirements. So the approach that we defined for having the exchange requirements and also integrated BIM BAS has the potential to mitigate interoperability issues and enhance data quality and consistency. The idea of this common data model can be used for supporting the decision making, so supporting this optimization strategies for the load management from the building perspective, and unlocking the potential of smart grid-ready building applications. As future work, we defined the comprehensive definition of BIM BAS exchange requirements, the development and deployment of the ontology itself to capture the semantics of the exchange requirements, and also the query code generator to create this common data model based on the exchange requirements. And that was it. Thanks so much for watching the presentation.